So first we'll talk about Bohr's postulates. Bohr's postulates, okay, all right. So if I talk about Bohr's postulates, first one is angular momentum of the orbiting electrons are quantized, right? So we can write L is equal to mvr, that is equal to nh cut. Here h cut is what? H cut is equal to h by 2 pi. H cut is referred as Dirac constant. Okay. So considering the circular orbit, if I talk about the orbit, okay, if I talk about the orbit, orbits are generally closed conic sections. So the proposal is orbits will be closed conic section. When we say closed conic section, sure Tulsi, sure. Closed conic section, there are 4 conic sections. If I talk about, one is circle, another one is ellipse, another is parabola, and the 4th one is hyperbola, right? Out of which these 2 are closed and parabola and hyperbola are open. So when we talk about orbits, which 2 orbits are allowed? 2 closed conic sections are allowed, whereas open conic sections are not allowed. That means parabola and hyperbola cannot be the orbits here. So if I talk about this existing setup, in this existing setup, we take a circle. So in circle, along the tangent, velocity will be there. So we can write linear momentum is also along mv, right? So here, this is angle 90 degree that you can get, correct? Yeah, as you wish, Raghavendra, as you wish. So now L vector, we know what L vector is equal to R vector cross P vector. So magnitude of L vector, I can write it will come RP sine theta. So if theta is equal to 90 degree, then L will become R into P, which will eventually become mv into R, correct? So L is equal to mv into R, all right? So from there we are writing mvr is equal to n into h cut, and this is the point which is proving that the angular momentum is quantized. But this is not the only point we need to discuss over here. There is some other point also. What is that point? Look at the force of interaction. If you look at the force of interaction, the force between these 2, F is equal to 1 by 4 pi epsilon naught ZE into E divided by R square. This is very simple, but if I look about the direction, then F vector will be equal to minus R vector. This is plus R cap, and this is the direction which is referred as minus R cap. Minus R cap, why we are taking? Because the force is attractive in nature. Since the force is attractive in nature, this equation can further be written as Z square divided by 4 pi epsilon naught R square into minus R vector by R, right? R cap I am writing R vector by R. So if you look at this quantity, if I take this entire factor separately, then you can see that force is coming to be proportional to R vector. And from there, we can write, what we can write over here? We can write R cross F, which is equal to torque, that is coming to be 0. And since torque is equal to 0, I am writing now, since torque is equal to 0, torque is what? Rate of change in angular momentum, that is also equal to 0. So if rate of change in angular momentum is equal to 0, angular momentum comes constant. So in Bohr orbit, when the electrons are orbiting, angular momentum is not only quantized, but it is also conserved. So the point I need to write over here is L is both quantized and conserved. L is both quantized as well as conserved. Okay. Quickly note it down if you want to note, or if you want to take the screenshot, please take the screenshot. Or if you are not getting the screenshot, then make some arrangement so that you can take a photo of it. Okay, done? Done. Shall we move on? Boys and girls, please respond. Shall we move on? Clear? Okay. Shall we move on? Please respond. I'm waiting for some more response. I will try, Pavitra. I'll try. I'm saving them. I'll try. Okay? Chal. Fine. Right. Chal. Next. I'll talk something more. Now let us talk about two more postulates very quickly. Number 2. It says what? No energy will be exchanged. No energy will be exchanged when the electrons are orbiting around the nucleus. When the electrons are orbiting around the nucleus. And this point also says that the orbits are stationary because they offer stable electrons. I'll come to that point later. Which are stationary and are referred as, the orbits are also referred as allowable orbits are referred as allowable energy levels specified by principal quantum number n. Be careful. The orbits are not random. They are specified by a specific quantity. What is that quantity? That quantity is the principal quantum number n. And what is the alternative definition? Alternative definition of the orbit is, alternative name. They are also referred as allowable energy levels. Many often, in questions, you will see they are not using the term called orbits. They are referring the term as energy levels. So the moment they call energy levels, you should know that they are referring orbits. Okay? Fine, Ravindra. Okay. Correct? Fine. Third point. What is the third point? Energy will only be exchanged when the orbiting electrons make transition from one energy level to the other. From one energy level to the other. That means whenever there is a shift in orbit. In bracket, this is also mentioned as whenever there is a shift in orbit. And what is the amount of energy change? Amount of energy change, delta E, is written as NH nu. Correct? And we also know that if the electron makes a transition from higher energy level to lower energy level, there will be emission of energy. And if the electron makes shift from lower energy to higher energy, there will be absorption of energy. Correct? यही तो बात है. Right? Two more points to remember. Two quick points. First point is L, that is equal to MVR, is equal to NH cut. This is known as Bohr's quantum condition. This is known as Bohr's quantum condition. And when we write second point, delta E is equal to NH nu, this is known as Bohr's frequency condition. So L is equal to MVR is equal to NH cut is called Bohr's quantum condition, and delta E is equal to NH nu is called Bohr's frequency condition. Very simple, ekdam rudimentary, fundamental things these are. Probably we have been studying all these things from class 10 onwards. Clear for everyone? We can move on now. Respond quickly. Please respond, everyone. Please respond. Waiting for your response, boys and girls. Shall we move on now? Okay. Okay. All right. Fine. Done. Good, good. Very good. Very good. Very good. Chalo. Okay. Next. Next, I will go for calculations, and for here I am not going to derive. ठीक है ना? I told you that if I go for the derivation, then it will take much time. You will not be able to finish. And basically, derivation is also not required for all of you because you have done the derivation before. I'll just stick to the derivations whenever it is required. So first of all, velocity function. Two equations we use. One, we use L is equal to MVR, that is equal to NH cut. And as I said, H cut is equal to how much? H by 2 pi. Another equation we use here is F electrostatic is equal to F centripetal. F electrostatic is equal to how much? Z square by 4 pi epsilon naught R square is equal to how much? MV square by R. All right. So if I use these two equations, then we get V is equal to how much we get? V is equal to, we get Z square divided by 4 pi epsilon naught NH cut. This is the equation we get for V. Right? Then we know that for H2, Z value is equal to 1. If we take N is equal to 1, N is equal to 1 is what? First Bohr orbit. And this is also referred as ground state only. So in that case, V0 is equal to what value we get? C by 137 is a standard value to be remembered. Velocity at the first Bohr orbit, that is equal to C by 137, right? No? Next. From here, in general, we express V is equal to C divided by 137 into Z by N. This is the general equation for V. Correct? Yes. Very good. Then next, Manas, thoda calculation check kar beta. Then for radius R is equal to what do you write? 0.529 into N square by Z in angstrom. This is also an equation to be remembered. Fine. Once we get the velocity, once we get the radius, now we can comfortably talk about the acceleration. Which acceleration here? Here acceleration is centripetal acceleration, that is equal to how much? V square by R. So I can write A is proportional to V square is how much? V square means Z square by N square. 1 by R means opposite हो जाएगा into Z by N square. So I get acceleration is proportional to Z cube by N to the power 4. This is another equation to be remembered. सब ये दोनों से आ जाएगा. Everything will come from these two only. That is velocity and radius. Every single thing, whatever we want to calculate. Akash, because there is a PPT. It's a PPT. Next, I'll look into more. I know that circulating charge is equivalent. Circulating charge is equivalent to a current loop. Circulating charge is equivalent to a current loop. So I can figure out the corresponding current. I is equal to how much, beta? E by T. T is equal to how much? 2 pi by omega. So it becomes E omega by 2 pi. Further, omega is V by R. So it becomes EV by 2 pi R. So I can clearly see that I is proportional to V by R. I will use this equation now. So I is proportional to V means how much? Z by N. By R means how much it will become? Z by N square. So current becomes proportional to Z square by N cube. I'll just keep on telling you, keep on writing. Easy feel हो रहा है? Clear है topic? याद आ रहा है सब? Are you getting the memory back? Yes, please. Please, Vaishnavi. You can take. Okay, good, Nikita. Good. Clarity है सबको? Things are clear? Good, good, good. Very good. Very good. The है ऐसे बहुत simple. This topic is actually pretty simple. There is nothing into it. बहुत जल्दी खत्म कर दो. देखना अभी next 5 to 7 minutes maximum. हो गया सब? Shall we move on to the next slide now? Can we? Yes, 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 absolutely, absolutely, yes. Yes, yes, yes. Done? Chalo, chalo, chalo. Sasipriya, I'll show at last because I'm saving all the slides, na Sasipriya. So at last I'll show one by one slide. ठीक है? Right. ठीक है. Let's move on. Next one. So since we have done about the current, next thing we will try to look into, as I have said, circulating charge. Circulating charge is equivalent to current loop. So definitely this current loop will create or will generate, will produce magnetic field at the center. So what is that magnetic field value? B is equal to mu naught I by 2R. So I can clearly see is B is proportional to I by R. B is proportional to I by R. Sorry. B is proportional to I by R. All right. So since B is proportional to I by R, now let us move on. So now this is proportional to I is equal to how much, re baba? Z square by N cube into 1 by R means Z by N square. So B proportional to it comes Z cube by N to the power 5. This is one more. अच्छा, बहुत सारे इंटरेस्टिंग थिंग हम रिवील कर सकते हैं. दिस इज द ब्यूटी ऑफ नोइंग थिंग्स इन प्रॉपर मैनर. यस आकाश, वेरी गुड बेटा. हाँ, तो नाउ नेक्स्ट थिंग इज व्हाट, एज आई सेड, करंट लूप. देखो, one by one we are just plucking the threads. It is there connected by dots. We have to just put the dots together to make the thread. So current loop is equivalent to a magnetic dipole, है ना? Current loop is equivalent to a magnetic dipole, right? Okay. So magnetic dipole moment mu is equal to how much? I into A. I is equal to how much we got? EV by 2 pi r. A is how much? Pi r square. So mu is equal to how much we got? We got EVR by 2. We have earlier learned that L is equal to MVR. So from there, VR is equal to L by M. If I go back and substitute here, we get an equation mu is equal to E by 2M into L. Got it? Mu is equal to E by 2M into L. Yes, everything we can derive, but problem क्या है, मानस एग्जाम हॉल में derive नहीं करना है. That's how a good student will save time, right? Whatever practice you need to do before the exam. Yes. So now look at this factor. This factor is E by 2M. It has a specific name, beta. All of you need to remember. E by 2M is called gyromagnetic ratio. E by 2M here is referred as gyromagnetic ratio. E by 2M is gyromagnetic ratio, not constant, Baba. Ratio, हाँ, constant भी बोल सकते हो. It's a constant term. Yes, absolutely. सब connected है. Everything is connected. We will go on further. What we can do? We can further write E is equal to mu is equal to. We have written MVR by 2 now. We also know L is equal to MVR, which is quantized NH cut. So VR can be replaced as NH cut by 2M. Now if I replace this here, so mu will become N into EH cut by 2M. Sorry, this is NH cut by M. So mu will become N into EH cut by 2M. Now when you look at this quantity, this is significant also, because this particular term EH cut by 2M is called Bohr magneton. What is this? This is the SI unit of atomic magnetic dipole moment. Bohr magneton. EH cut by 2M is called Bohr magneton. Things are clear to everyone? Quickly respond. Everything you know. I'm just recollecting back your memory. ठीक है सर? All my dear friends, एकदम crystal clear. Respond fast. Respond fast, please. Everyone, quick. Absolutely clear now. Good. Very good. Okay. Right? ठीक. Okay. ठीक है. चलो, let us move on. Right. Yeah. So this is just to put your reminder. Fatafat. You have done this well in brief in chemistry. Just to tell you quickly, there are 4 graphs. You can remember, very easy there. First is R versus 1 by Z. second is R versus Z, third one is R versus N square, fourth one is R versus N. Very, very simple thing it was. If you see the first one, here y is equal to R and x is equal to 1 by z. So this is in the form of y is equal to mx. So this will be a straight line. Next one, y is equal to R, x is equal to z. So it is in the form of y is proportional to 1 by x. What you get here? You get a rectangular hyperbola. So for rectangular hyperbola, this is the graph. Third one, again, y is equal to R and x is equal to n square itself. So again, you get a straight line passing through the origin. Very, very simple things. Next, you get y is equal to R and x is equal to n. So hence you get y proportional to x square. Y proportional to x square is a parabola. So since it is a parabola, you get a graph like this. Now you have to remember that full parabola looks like this. We will only show the right hand side. Correct? Half fourth is a parabola. But इसमें क्या करेगा? You will have a change. If this question comes in the exam, they will take a minor tweak to this question. What is a minor tweak? They will do n versus r. That's the only change they will make. So when it is n versus r, what you are getting here? If it is n versus r, you are getting y square is proportional to x. So that is also a parabola. This is also a parabola, but the nature of the parabola will be a little different. Now the parabola will be like this. So please be careful. एकदम simple है, बहुत simple है. Just be careful about the last one I have shown. If the graph is reversed, if they are asking n versus r. तुलसी बेटा ये डाउन तो नहीं होगा. This is a PPT only. I'll write. This is basically n. The only thing you are not observing here, na? This is n versus r graph. I have plotted n here. This is n versus r. Okay. Clear है सबके लिए? कोई डाउट नहीं है? Absolutely easy. Very simple it is. है ना? All right. Shall we move on now? Shall we move on? Shall we move on? Please respond. Shall we move on? Done, boys and girls? Please respond quickly. Okay. Okay. ठीक है. हाँ मधुनिका. Fine. Okay. Okay. ठीक है ना? बस वो मेमोरी वापस आना चाहिए. That's it. Clear है? And when you practice such things, my suggestion will be keep on writing them, write and practice. Because if you just read, no, you will not be able to remember. It's very difficult if you just read and try to remember. So you have to continuously write these things, including the derivations. Then only you will remember them properly. ठीक है? चलो. Move on. So here we'll discuss a very, very interesting thing. 2-3 interesting things we'll discuss, which will be useful for us. चलो. So basically in the diagram, there is nothing. We can see that whenever the electron is making a transition from lower state to higher state, there is absorption. And when it is coming down from higher to lower, there is emission. But I want to talk about that. When we want to talk about that, we all know number of emission spectra. Number of emission spectra is represented by n into n minus 1 n into n minus 1 divided by 2. At the same time, number of absorption spectra this number is given as n minus 1. Please be careful about these two things. When we talk about number of emission spectra, this emission spectra is also called bright spectra. Number of absorption spectra are also called dark spectra. The number of dark spectra is n minus 1, whereas absorption spectra is n into n minus 1 by 2. But let us think about a transition now. Now I'll give you a very, very interesting insight. You know that, but now I'll make you understand to think in a different way. Suppose an electron is making a transition from n is equal to 3 to n is equal to 1. And in between n equal to 3 and 1, there is n is equal to 2. So I am asking two questions to you. Now this will be really, really interesting. What are the two questions? First question I'll ask, find the number of spectra possible. This is one question. Then I'm also asking number of spectra visible. This is also a question. We have to think. Initial thinking will be, sir, बकवास क्वेश्चन है, डब्बा क्वेश्चन है ये तो, दोनों तो सेम होना चाहिए. Number of spectra possible, number of spectra visible, दोनों का number same होना चाहिए. Both should be same, but no, it's not. Why? Because when we see the transition, we know that either it can come down from n equal to 3 to 1 directly. So let us say this wave number is called nu31 bar. Or it can make in steps. It can come down first from 3 is equal to 2 and then 2 to 1. If this wave number is 3, 2, if this wave number is 2, 1, there is one principle which say, the name of the principle is called Ridge combination principle. Ridge combination principle, which says nu31 bar is equal to nu32 bar plus nu21 bar. So when I ask the question number of spectra possible, your answer is equal to 3. There is no problem into it. 1, 2, 3. The number of spectra possible is 3. But when I ask number of spectra visible, visible number will be how much? My answer will be either 2 or 1. Please be careful. When I say number of spectra visible, it is either 2 or 1. Why I am saying so? Because when the electron makes direct jump from 3 to 1, if the electron is directly jumping, then this step jump will not be visible. Vice versa. If the step jumps are visible, direct jump will not be visible. So answer will be either 2 or 1. Yes, Amrut. You understood the concept? ये पूरा गेम समझ में आया? I repeat once again, number of emission spectra or bright spectra is n into n minus 1 by 2. Number of absorption spectra will be equal to n minus 1 corresponding. Then I'm taking an example. I'm saying if the electron makes a transition from n equal to 3 to 1, it will be possible in two different ways. Either it will come down from 3 to 1 directly, or it can also come down by subsequent steps. It can come down from 3 to 2 and then 2 to 1. Sirisa, both will not be visible because both cannot happen simultaneously. That's the point. Listen to me. I'm saying both cannot happen simultaneously. If the electron comes from 3 to 1 directly, then it is not coming in steps. Correct? And if the electron makes step transition, then it is not coming in directly. So that means either in one time you will see one line, or if they're coming in steps, you will see two lines. But you cannot see three lines at the same time. You will either see one line or you will see two lines. Raymond, what is N? Principal quantum na marunga na be? Okay, clear? Done everyone? ठीक है. Hemant asking, sir, what is n initial orbital value? I'll discuss, Hemant. No. N is the number, purely number. I'll come to that point. Just wait for some time. Okay? This is clear? Understood? No doubt is there. Right? Shall we move on? Screenshot done, photo done, everything is clear. Shall we move on now? No doubt. Correct? Okay. I'm moving on. Fine. Next slide. So here, you know all these things. I don't have to discuss. I just came to this page to discuss two things. 2 points you need to remember from here. What are the points? First of all of you know. What do you know? 1 by lambda. This is called wavelength. Sorry, wave number. 1 by lambda is called wave number. How to define wave number? Wave number is basically number of waves per unit path length. Number of waves per unit path length. If you look at the dimension, 1 by lambda dimension is equal to L to the power minus 1. Very funnily, if you check the unit of Rydberg constant is also meter inverse. So you should remember, dimension of Rydberg constant is also L to the power minus 1. So here wave number and Rydberg constant, these two quantities, they are dimensionally equal. They are dimensionally equal. And this is the most important equation that we are supposed to remember. I hope all of you remember. So I'm not going much into this equation. We will just solve questions from here. ठीक है sir? Enough information? Am I allowed to move on now? Quick. I just need 5-6 minutes more in theory discussion. We'll go into questions shortly after that. Respond everyone quickly. Shall we move on to questions? Next topic, next slide. Okay. Right. Fine. Okay, moving on further. Next. This is unimportant. Yeah, come to this. So there I just want to discuss only one point. That's a very important point, significant point. The point is, see, if you look at this particular diagram, you know Lyman, Balmer, Paschen, Brackett, Fund, Humphreys, all things are there. But if you move on, the energy difference is decreasing subsequently. So as you increase the value of n, the energy difference between two subsequent orbits will also keep on decreasing. Let us understand why that's happening and what is the outcome of it. Please understand that now I'll write chronologically, as I write every time. First I will write the logic, then event, then outcome, then what ultimately we will get. You also remember in that same fashion. If principal quantum number is very high, if n is very high, we know radius of the orbit is proportional to n square, which is also very high. That's very large. If the radius of the orbit is very large, then the force of attraction, which is proportional to 1 by r square, it's very less. So we can write force is tending towards 0. If force is tending towards 0, then I can write the electron is virtually free from the nucleus. Electron is virtually free from the nucleus. If the electron is virtually free from the nucleus, then its energy is no longer quantized. Why it's no longer quantized? Because energy can be quantized. This quantization only related to bound particle. So this is related to bound electron. For a bound electron, you have seen that total energy becomes negative. For a bound electron, only total energy is equal to negative. But here the electron is free. So if the electron is free, then the electron can have any energy ranging from 0 to infinity. When the electron can have any energy ranging from 0 to infinity, then the energy range is so high that you will not be able to see distinct spectral lines. Rather than that, you will see a continuous band here. So what will I write here? I'll write since energy range for what? For the free electron is so high, no distinct spectral lines will be visible. Rather, they will appear as a band-like structure, and this region is named as continuum. If possible, please remember this. This region is named as continuum. Idea clear, sabka? Physics clear? Whatever event I have discussed, is this clear to you? Respond quickly. Fast response, everyone. The events are clear to all of you, categorically understood. Boys and girls, my dear friends, fast response. Quick. Okay. Okay. Fine. Fine. All right. All right. Fine, everyone. Done. Shall we move on? Shall we move on? Shall we move on? Yeah? Fine, good. Okay. Okay. Chal. Very good. Thank you so much for your kind cooperation. Thank you. Well, so here I don't have much things to discuss in this slide. I have only one thing to tell you. What is that? Please do remember there is only one series. Which series? It's a Balmer series. It's only Balmer series which is in a visible region. It is only in the visible region, and in this visible region the color changes from lambda minimum to lambda maximum. What is that minimum wavelength? It is 4000 angstrom. Maximum one is 7000 angstrom. Minimum wavelength color is violet. Maximum wavelength color is red. Are Vibgyor na re baba? Vibgyor is there. So देखो color changing from violet to red. Wavelength is changing from minimum to maximum. You have to remember, when wavelength is minimum, that time frequency is maximum. When wavelength is maximum, that time frequency is minimum. So that's the only point I need to discuss from here. So Balmer series, we will remember like it is in the visible region, right? If it is in the visible region, below it, Lyman series in the ultraviolet range. How to remember? Below violet, that's why ultraviolet. If you go above, if I talk about the Paschen series, in this series it is near infrared. Very simple to remember because this Paschen is closer to this red line, so that's why near infrared is there. And this is Lyman below the violet one, that's why it is ultraviolet. So this is the only information you need to remember from here. Please remember that wavelength changing from 4000 angstrom to 7000 angstrom in the visible region, color changing from violet to red, and that series is Balmer series. Okay, fine. Manas is a great debatable thing because the wavelength range is not properly defined in case of classical radiation. As per the quantum radiation, we can take them into the far infrared bracket only, but yes, we can also remember in the medium IR bracket, no problem. Okay. ठीक है, आगे बढ़े. Shall we move on? Chalo. Let's move on. Not required. Let's come into the questions. Chalo. These two quickly, one by one. One by one. First one we have already solved, so I'm waiting for the answer. I am waiting for your answer. I am waiting for your answer. This one, what is the answer? Tell me quickly. Very simple. What they are asking? They are asking the ratio of magnetic dipole moment to that angular momentum of the electron. Mu by L they are asking. Mu by L they are asking. If you are not wrong, it is E by 2M. We have the equation. You remember? We said mu is equal to E by 2M into L, or we wrote mu is equal to N into E H cut by 2M. Two equations. It is fitting with this one. So E by 2M is the answer. Everyone clear by E by 2M? Yeah. Okay. Okay. Fine. Very good. Very good. Proud of you. Next, do this one. Boys and girls, do this one. We have done the formula. Joel 15. Very good, beta. Very good. Very simple. You see here, they have said number of dark is n minus 1, that is equal to 5. You see here, 5 dark lines are observed. Dark lines means absorption spectra. So n minus 1 is equal to 5. So n will become how much? 5 plus 1, this is equal to 6. They are asking what? The number of bright lines formula. Number of bright lines is equal to n into n minus 1 by 2. 6 into 5 divided by 2. So the answer is 15. देखो सब easy हो जाएगा अभी इसके बाद. Yes, Kavya. Yes, Pavitra. Good. Very good. Rama good. Stika good. है ना? Easy है ना दोस्त? बहुत simple है भाई. Just remember the concept. बाकी game सब easy हो जाता है. Questions are very easy from here. Not difficult at all. Shall we move on now? चमक गया एकदम. बस वही चाहिए. Right? Screenshot ले लिया. Okay. चलो. Next one. चलो. Sorry. Next one. Acha. Next one. The first question you can do, all of you. I'm not expecting that. What I'm expecting, please solve this one. Second one. All of you saw second one. Yes, Akash, I will keep the screenshot for all the slides because I'm saving all the slides. No, so at last I will show them one by one for 5 seconds. Second one, all of you do. Second question, all of you do. देखो बहुत simple है. What is the simplicity in this question? Try to understand what they are saying. They are saying difference of spacing between the energy levels. Sir, you told us energy levels. Energy levels means they are nothing but orbits. All right. So if they are orbits, means this is suppose n equal to 3. This is n equal to 4. This is R3. This is R4. Spacing means they are asking this. R4 minus R3. What is the other quantity? R9 minus R8. So they are asking R4 minus R3 divided by R minus R8. Well, all right. Do we know R is proportional to n square? We know, sir. Then this will become 4 square minus 3 square divided by 9 square minus 8 square. 16 minus 9 divided by 81 minus 64. So this is coming 7 by 17. 7 by 17 is approximately 0.41. Yes, option 2 is the correct answer. Good, Pavitra, Joel, well. Understood everyone? नहीं, 4th is not the answer है बाबा. थोड़ा गलत हो गया. Yes, Sikar. Good, good. Everyone understood? Please respond. Everyone understood? Correct now? Yes, yes, Sirisha. Yes. Right? Okay, chalo. Few more questions, 2-3 more questions. We are done. Right. Let us come. Both these questions now, boys and girls. Please go through both these questions one by one. Come on, my dear friends. First this one, then this one. First, look at the question, what they're saying. First line of Lyman series. First line of Lyman series means n1 equal to 1, 2, n2 is equal to 2. So we'll put the formula 1 by lambda is equal to rz square into 1 minus 1 by 4. They have mentioned hydrogen atom. So z is equal to 1. So simply it becomes r into 1 minus 1 by 4, that is equal to 3r by 4. Fine. Next, what they are asking, velocity acquired by the atom when the photon is hitting. Well. Conservation of linear momentum. Initial momentum of the photon is equal to final momentum of the atom. What is the initial momentum of the photon? H by lambda. Final momentum of the atom is how much? M by V. We already got 1 by lambda. So this becomes 3RH by 4, that is equal to mv. So V becomes 3RH by 4m. Very, very simple. Extremely easy. Yes. Yes. Absolutely easy. Clear, Baba? Yes. Well, Srikar, Pavitra, good. Very good. Clarity है सबको? Done this one? Fine? Clear now? Right. Chalo. For the next one. Ratio between the total acceleration of the electron in singly ionized helium and hydrogen. Acceleration. Whoa, we have done, sir. Acceleration is z cube by n to the power 4, sir. They are saying both in the ground state. So n is same for both of them. So A is proportional to z cube, sir. Fine, sir. A helium by A hydrogen is equal to z helium by z hydrogen whole cube. Simple, sir. 2 by 1 whole cube, that is equal to 8, sir. Done, sir. Yes, Pavit. That's how much easy they are. Extremely easy they are. Very, very easy. Yes, Rupa. Good. Understood now, everyone? क्लैरिटी आया सबको? Everyone got clarity? Shall we move on now? Right. Chalo. Not required, you can do. No, this one also you can, I think potentially everyone can solve. We will discuss these two quickly. These are the last two questions we are discussing for today. Boys and girls, come on, one by one. Those are easy questions, Yashwini. You can easily do it. Whatever the quality questions are there, I'm only trying to discuss them. Yeah. Yes. So here you see the potential they have given. Potential is equal to V naught log of R by R naught. Well, potential energy is equal to charge into potential. It will become E V naught log of R by R naught. Fine. We can find force from here because force is equal to, we know, du dr. So we will get something into log of derivative means 1 by R we will get. Now this force is equal to how much? This force is equal to centripetal force mv square by R. Well, gosh, R gets cancelled. It means velocity of the Bohr electron you get constant. So if velocity is equal to constant, boys and girls, L is equal to mvr is equal to nh cut, because they are saying that it will follow Bohr model. So m is constant, v from the equation become constant, r is simply proportional to n. So that's your answer. It is a good question, right? And for this question we have solved already. Fourth one is the answer, z cube by n to the power 5. Right? Clear, everyone? Did you got it? You got it? This one we have solved earlier already. This one is done already. Magnetic field at the center, we have solved it. It came z cube by n to the power 5. We have solved already. Right? ठीक है? Clear, everyone? Done and dusted. I am keeping these questions. You take the screenshot of this question. You try this at home. These are homework questions. Take the screenshot or take the photo of it. All right. Take these two questions also. Okay. Fine. I'll send the PPT, Yashwini. I'll send. Take these two. ठीक है? All right, chalo. Now I'll go to the written saved files. I'll show them one by one. Take quick snapshots from each of them. है ना? Chalo, take this one first. That's why I'm saying now, if you are not allowed to take the screenshot, do one thing, take photo from it. Right? Chalo, don't worry, no problem. Bye for today. I'll take the photo, I'll send it in the group. Don't worry. I'm taking the photo right now. I'll send you to the group. I'll send shortly. Okay? No problem. I'll take the photo. Right now only I will share in the group. Don't worry, don't panic. I'll share. It's my responsibility. Okay? Chalo, bye-bye. Love you all. See you in the next class. Bye-bye. Bye for today. Bye everyone.